Hi friends, so in the earlier videos we were learning about how we can reduce an ER model to a minimum RDBMS design. We have seen certain examples associated with that. In this video we are going to learn about some more example associated with that and how we can actually reduce this ER model into minimum RDBMS design. So let's begin with one of the example. Let's say E1 and E2 are the entity sets. Okay. By the way, till now we are learning about the binary relationship where we have the two entity set associated with one relationship set, that is R. But in the real practice, it won't be the scenario always. There could be a lot many entity sets and relationship sets, and there you need to understand how we can convert that model into a minimum RDBMS design table. Okay, and of course there will be certain constraints that for example, for this example we have this 1:1 mapping, that is 1:1 mapping between the entity sets, and there is a total participation constraint also involved. Total participation constraint I have already covered up in the earlier videos, where we see that all the entities of one entity set is associated with every other entity of other entity set E2. Okay, and at least with at least uh, one end with only a single valued attribute. Okay, this also has been covered, the single valued attributes and the multi-valued attributes. Okay, so we have two entity sets, E1 and E2, which are related by the relationship set R with 1:1 mapping, and there is a total participation. Okay, and with at least one end with only a single valued attribute. Let's see how it comes in the diagram. So this is our E1, and there is a relationship set, that is R. There is another entity set, that is E2, and we have two keys. One is A, is the candidate key for E1, and for E2 we have two keys. One is C, is the candidate key of E2. For R, definitely we have A and C, and since it is 1:1 mapping, so and also total participation, so A and C both are the candidate key for R. Now let's see how we can combine these into a single table. Let's say A1, A2 and A3 are the entities of the entity set E1. I mean A1, A2, A3 are the values of the attribute A for each entity. Okay, and for E2 similarly we have this C1, C2, C3, C4 and C5. Okay, okay, it came in D, but actually this is for the values for the attribute C, and A1 is related to C1 because A2 is related to C3 and A3 is related to C2. So there it is a total participation. So it is not necessary that we have the total participation at both the ends. So let's say we have this total participation at even side. Okay, right? We don't have the total participation at E2 side. It will be partial only. Why? Because these C4 and C5 are not involved in this relationship part. So this is total participation, let's say at the one end. Okay, now what we can do, let's say we can combine them as a one diagram like E1, E2 and R. Okay, so definitely it will have the attribute A, B, C and D. So values of A equal A1, A2, A3. A1 is related to let's say A1 is related to C1 and A2 related to C3. So here Okay, A1 is related to C1, A2 related to C3, and A3 related to C2. Apart from that, we have C4 and C5. For that, we have null values for A. Okay, similarly, we have the values B. This will be also null, or let's say it accommodates some value, or null maybe. I don't know. So let's not consider this. So this way, if we have combined this as a, RDBMS table diagram, so if you see both A and C are keys here, but C is definitely the candidate key as well as the primary key for this RDBMS table design, while this could be an alternate key or simply a candidate key but not primary key because of these null values, because we know in our RDBMS table design, primary key is the one which has no null values. Okay, so this way we can combine it as single table. So minimum RDBMS table is equal to 1. Okay, and no foreign key, of course, because we don't need any foreign key here. This will be the alternate key and this will be the primary key, right? So this could be the design. Let's say if we have the total participation at both ends. So here we had a total participation at only one end. Let's say for the same diagram, if we have the total participation at both ends like this. So this will be even, and the relationship set R, and we have E2. Okay, for even we have two attributes A and B. For E2 also we have two attributes C and D, and C being the primary key here, and we are combining them as a single. So if we have the values here A1, E2, A3, and we have the values here C1, C2, C3, and let's say A1 is connected to C1, A2 is associated with value C3, and A3 is associated with value C2 here in relationship set R. Okay, so if we combine them as one single relationship table, so even R2, okay, so it will be having the entities as A, B, C, and D. So for A1, A2, A3, we have the association as C1, C3, C2. Okay, and there will be values. So this and this both are the candidate keys, of course, and with none null values. Okay, either one of them could be the primary key. Okay, we can treat either one of them could be the primary key, and so minimum, it will be minimum RDBMS table. Okay, with no foreign key, right? We have already seen about the one-to-one relationship table diagram, right? And what will be the minimum? So when there is one-to-one mapping, sorry, it's not 1:1 mapping, it is one-to-one mapping. So when we have this one-to-one mapping, plus we have a total participation either at one end or both end. If it is at one end, okay, so what will be the outcome? There will be minimum RDBMS table that will be equal to 1 with no foreign key, one primary key, and one alternate key. Okay, and if we have the same 1:1 mapping, plus the cardinality constant is total participation at both ends, then we have the minimum RDBMS table as equal to 1 plus we have two candidate keys. Either one could be treated as the primary key with no null values plus no foreign key. Okay, so this is one basic overview of how the relationship diagrams, entity relationship model could be converted into minimum RDBMS table. We already have seen earlier that if we have these two entity sets and it is a 1:1 mapping, but we have partial participation at both the ends, right? Let's say this B and C and D, and we have it is 1:1 mapping only, but we have the partial participation at both ends. For example, some of the entities of A1 are mapped to, let's say, C1. Okay, these are the entity set for A1 and this for C1. So, sorry, C. So, let's say A1 is map to C1 and A2 map to C5 and A3 map to C2. Okay, so there it is not total participation. Here it is partial participation at both the ends. However, it is 1:1 mapping. Okay, so if we combine them together into one single RDBMS table, that would be like E1 R E2. So it will be something like A, B, C, D would be the columns, and the values could be like A1, A2, A3, A4 and A5. For A1 we have the mapping as C1. For A2 we have the mapping C5, C1, C5 and C3. Okay, is it C3? Okay, C2. A3 is mapped to C2, right? And then we have for A4 we have a null. Okay, we are mapping it to B. It should be actually I'm sorry for that. So it should be C, B and D. Okay. For this we have null, and we have two values of C left, that is C3 and C4, and here we have a null. Okay, so this way, right? And then we have B, values of B, and similarly we have values D. Okay, so you see here we have these two can be considered as the candidate key. These two can be the candidate key or alternate key, but they cannot be treated as primary key because they have these null values there. Okay, so no primary key in our RDBMS table design. Hence, this table is not valid. Not a valid RDBMS table because we don't have the primary key here, right? So definitely the minimum RDBMS table equal to 2. Okay, so either we could combine any two of them. Okay, right? Like we can combine even R. So if we are combining even R and E2, so here we have A, C, B and A1, A2, A3, A4, A5, and for A1 we have C1, A2 we have C5, A3 we have C2, A4 a null and A5 null. So this way we have two candidate key, but this will be the primary key and this will be the foreign key for this. Okay, foreign key referencing to this. So this will be the minimum RDBMS table design, right? With two tables in it, and the foreign key will be 1, primary key will be 1 and alternate keys will be 1. Okay, so this way we can have this 1:1 mapping, with partial participation at both the ends, right? So that is why the constants we had already seen in earlier videos are necessary, because they help us to determine how we can convert this ER model into a minimum RDBMS design, right? So this was all about the 1:1 mapping. So I am writing this 1:n mapping. This I may need to let you understand about all these. Okay, this is 1:1 mapping with the constants. Okay, I'll illustrate also about 1:m mapping. We already have seen about m:(n) mapping. I will definitely illustrate it here. Like if we have m:(n) mapping, this way for both the constants, for partial as well as total participation. So for both of them, if we have these two entities like even and there is a relationship R and E2 is there another entity set, even with two attribute A and B. Let's say A is the candidate key. For E2 also we have two attributes C and D with C as the candidate key, and R we have A and C, and we know already that both is together act as a candidate key. So let's say we have values here A1, A2, A3, A4 and A5. Let us assume it as total participation, or let's say partial participation only. It doesn't matter, C1, C2, C3, C4 and C5, and there will be mapping as A1 is mapped to C1 and A1 is mapped to C2, A2 is mapped to C3 and A2 is mapped to C4 and A3 is mapped to C5, right? This way. So let's convert it into two minimum two tables. So let's combine E1 and R and E2. Okay, so let's see what happens. A, C, B and C and D. Okay, right. So here it will be A1, A2, A3, A4, A5. Right, A1 is mapped to, let's say we have A1 mapped to C1. Okay, we need to consider all the scenarios. So just a second. Okay, so A1 is mapped to C1. Also A1 is mapped to C2. A2 is mapped to C3. Also A2 is mapped to C3. Right, and then we have A3 is mapped to, sorry, A2 is mapped to C4, right here. And then we have A3 mapped to C5, okay, this way. So this way it is mapped. Here it is m:(n) mapping. So C5 is also mapped to A4. Okay, so A4 is also means 1:, here we are considering m:(n) mapping, that is m:(n). For that C5 is also mapped to A4 and also it is mapped to A5. Okay, so C5 is mapped to A3, A4 and A5. So C5, A4, C5, A5. Okay, so this way it has gone, and then we have certain values for B here. Like you see here, it is a total participation, m:(n) total participation, but it is an m:(n) mapping. Like this is mapped to m entities and it is also mapped to n entities. Okay, that is why it is m:(n) mapping and total participation, right? Total participation. Okay, so here if we see And here we have a C1, C2, C3, C4 and C5. So C is the candidate key here, right? So this is one table. Now if you see for this table, we have this is not the candidate key, this is also not the candidate key, but if we treat it as one, like if we treat it as together, so A5 C5, A4 C5, A3 C5, A2 C4, A3 A2 C3, and then we have A1 C2, A1 C1 together. It is acting as if we say it is a candidate key or a foreign key, sorry, a primary key, because it has no null values. So this could be the scenario, but here we have this repetition of A1, A1, then A2, A2, A3, okay, and then A4, A5. Similarly, we have C1 and then C2, C3, C4, C5, 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 right? So this is the repetition. So we can't treat only one attribute as the candidate key or primary key. Both together will act as a candidate key or a primary key, right? It is in the case of total participation with M is to N mapping, right? So you need to consider this with so it is M is to N mapping with total participation. So in this way, if we combine, then this act as a primary key or candidate key. Here the candidate key becomes AC, and if we consider the foreign key, so C can be referring to this C, okay? So C is referring to this part, right? But this is not the candidate key as alone, right? Here we don't have the C as the candidate key like C1, C2, C3 and C4, C5. It is not the candidate key. It has values repetition, right? So in this way we can combine, but we'll see next what are the issues that it causes when we do this way, right? We can combine them as one particular table here. This as act as a one table, and this act as another table, right? Just a second. Okay, so this act as one table, and this will act as another table, but we need to have one foreign key here. So the foreign key would be obviously could be C. If C is our foreign key, C is definitely not the candidate key for this. So C will be referring to this particular candidate key C or the primary key C. Okay, so in this way we can do the relationship set and entity ship set to reduce to a minimum RDBMS design, right? We'll see next few more examples of how we can proceed with the RDBMS design for the ER model provided. Okay, for that, goodbye and see you next in the next video.